Hello everyone, in this video I'm going to explain you the problem leaf similar trees. So basically in this problem they are saying they have given two trees and then we have to find the leaf nodes from left to right and then see if those leaf node sequence are same or not. So let me take example and explain you what they are saying. So they have given here two trees and they have given in the form of array. So basically they have given only the root nodes and this array represents level order form. As you can see, three children are 5 and 1. So in this case 3 children are 5 and then 1, and 5 children are 6 and 2. From here as you can see 6 and 2, and then 1 children are 9 and 8. So all children are 9 and then 8, and then 6 children are nothing, so it is null, and 2 children are 7 and 4. So 2 children are 7 and then 4. So in this way for this also they have given. So basically they have given in level order form. In this case we have to find the leaf nodes, and from left to right whatever the leaf nodes we are getting in both trees we have to check if they are same or not. So as you can see, first one is a 6 and here also first one is 6, so it is same. Second one is 7 and 7. Third one is 4 and here is also 4. Fourth one 9 and then 9, and fifth one 8 and fifth one 9. So in this case we need to return true because the sequence of leaf nodes from left to right in both the trees are same. Let me take one more example. So in this case as you can see the sequence is like 2 and 3, but in this case it is 3 2. So 2 is not equals to 3. So in this case the sequence are not same, so we have to return false. I think you got the problem statement. In order to solve this, what we can do is we can traverse through the entire tree, binary tree, and we can find all the leaf nodes. Whenever we encounter a leaf node basically can be found using like if that node has a left children or right children node. If both does not, like that particular node does not have left children and right children, so in that case that can be treated as a leaf node. So basically what I'll be doing is I'll traverse through the entire tree and then I'll find leaf nodes, and then those leaf nodes I'll store in a vector. For this particular tree I'll store in a vector v1, and for this particular tree I'll store in a vector v2, and at last I'll compare first the size of the tree size of the vectors. So basically in order to for both the trees to generate same sequence, so the length has to be equal, and then if lengths are equal then we have to check particular elements at particular positions, like they're occurring in a sequence or not. So this is our main idea. So let me write one function. So they have given function name as leaf similar, and they have given root 1, let me call r1, and then root 2 they have given, let me call r2, and its return type is boolean. So here I'm writing pseudo code. What I'll be doing is, so first I'll take a vector, let me call vector as v, which will be of type int, let me call v1. Then I'll call one more function, and function name I'll keep as find leaf nodes. So in this function what I'll do is I'll pass the root, and then I'll pass this vector v1, and I'll pass this vector v1 by reference so that any changes made to that vector will be affected in that vector. So basically I'll write this function. What I'll be doing in this function, I'll be basically counting the number of leaf nodes, not number, basically the leaf nodes I'll be storing in vector. Similarly I'll do for for root 2 also, like second tree. So I'll initialize vector of type int, I'll call v2, then find same function, I'll count find leaf node, I'll pass r2, root node of the second tree, and then I'll pass v2. So once I get both the vectors, first I will compare if v1 size not equals to v2 size, which means the leaf nodes of the sequence 1 and 2 are not same. In that case, so the sequence will not be same, so we have to return false. And if suppose like size of the both sequence are same, but then we have to compare the individual elements if they are same or not. If all the individual elements will be same, then we have to return true, or else we have to return false. So for that case, I'll be traversing through the entire vectors from I to v1 dot size or v2 dot size, because v1 and v2 will be same. If both are not same, so it will go into this loop and return. And if both are same, then only here will come, and then you can use any one like v1 or v2. So here we have to compare if v1 of I, that particular element, if it is not equals to v2 of that particular element. So if they're not same, then it implies sequence are not same, so then we have to return false. Else like if this for loop gets executed and if it does not fall into this if condition, which means all elements are same, so at last we have to return false, true. So this is our algorithm, like pseudocode. So we need to I'll write this algorithm for this find leaf node. So find leaf node return type is void, and it is taking root of any tree, and then it is also taking vector by reference. So here what I'll be doing is I'll check if that particular root's left child is null and right child is null, then in this case it is a leaf node. So as simple as it is a leaf node, then what I have to do is I have to push back this value into the vector root of value, and I need to simply return it, because since it is a leaf node, then there is no child, so we need not to check any other thing. And if suppose that particular node's left child is null and right child is present, so in that case we need to move to the right child, because that particular node will not be the root leaf node, but later we might get, so we have to move to the right side. So here I'm writing root of left is equal to null, then we need to call this function. I'll name in short form as find leaf node. I'll move to the right side, and then I'll pass the vector. And else if let's say for that particular node left child is there but right child is not there, so which is root of right is equal to null, which implies right child is not there, left child is there, so we have to move to the left child, so that in future we might get any leaf node. So in that case we'll call this function find leaf node on root of left, and I'll pass that vector v. So from here, as you can see, we have handled cases like where for that particular node both childs are not there, so it is a leaf node, and only left child is there and only right child is there. But then there will be a nodes wherein both for that node both childs will be there, left and right. So in that case we need to call this function on both sides. So at last it will be else find leaf node on, first I'll call on root of left and I'll pass the vector. Also I'll call on root of right. So once we do this, we will be finding the leaf nodes, and here as we are comparing like sequence or equal node, and then we are returning. So let me write the code. First I'm taking a vector, let me call v1, and I'll call find leaf node on root 1 first, and then pass this vector. Also I'll take vector v2 and I'll call on tree 2 root 2, and let me pass this vector v2. So let me write this find leaf node function. So its return type is boolean, and we are passing the node root. Also we're passing the vector, and I'll pass through reference because any changes I'll be making in the code will affect the vector. So what was the case, like if root of left equals to null and root of right equals to null, which means it is a leaf node. So in that case we have to push back this value into the vector, and then we have to simply return. If this is not the case, let me take one more case. If root of left equals to null, which means we don't have left child, so in that case we need to move to the right child. And let me pass this vector. Else if root of right equals to null, which means we don't have right child, so in that case we'll move to the left child. And if these are not the cases, then at last like that particular node will be having both left and right child, so in that case we have to move to both sides. Have to move to right side also. So after executing this line, we'll be having sequence, and after this also we'll be having sequence for tree 2. So first I'll be comparing if v1 dot size equals to v2 dot size, like not equals to. If sequence length are not equal, which means sequence will not be equal, so in that case we'll directly return false. So if sequence length are equal, so we have to check one by one the elements of the sequence. We can take anything like v1 dot size or v2 dot size because both are the same size. And we need to check if v1 of I is not equals to v2 of I, which means that particular elements are not equal, which means sequence will not be equal, so in that case we need to directly return false. And if we come out of this loop, which means all the elements of the sequence are equal, so in that case we need to return true. So let me run the code. Its return type is void. Now let me submit the code. So it got accepted. One more thing I want to focus is that don't believe in this bit 29% or 47%, because when I submitted this code previous time, the same code I written, and as you can see same code we have, and in this case it was like it beats 100%, but now the same code when I run it is like 29%. So don't believe in this. I don't know how this works, like how this leetcode people has put logic and all stuff, I don't know, but don't believe in those things. So let me analyze the time complexity of this algorithm. So as we are seeing, so we are basically moving to the entire nodes of the tree, both the trees. So it will be of O of, let me take n1 be the number of nodes of the tree 1, and then n2 be the number of nodes of the tree 2. So time complexity will be O of n1 plus n2, and then space complexity will also be O of, let me call k1 plus k2. So where k1 is implies the leaf nodes of tree 1, and then k2 implies leaf nodes of tree 2. So both time and space complexity are linear. So thank you guys for watching my video.